Good morning, everyone. I'll be the reporter for today. My topic is Chapter 7 Experimental Research Strategy. Okay, what is an experimental research strategy? An experimental research strategy is a strategy that aims to establish the existence of a cause and effect relationship between variables. In a basic sense, the experimental research strategy is the strategy to determine which is the cause and which is the effect in a phenomenon. There are specific goals of the experimental research strategy. Number one, it's to demonstrate that the cause happens before the effect. And number two, to establish that one specific variable is responsible for the changes in the second variable. Okay, these goals are very important because in the process of the experimental research strategy, there are so many variables and factors to be observed that there are times that the researchers confused or the researchers fail to determine which is the cause and which is the effect. So in the simplistic sense, we need to determine that the cause is solely the cause and there are no other factors that would elicit the seen or observed effect. This is important because there are variables that can affect, or what we call, there are variables that can influence the cause and will alter the effect. Okay, so number two, to establish that one specific variable is responsible for the changes in the second variable. Okay, the goal of experimental research is to determine that one specific variable is responsible for the changes in the second variable. It means the experiment or the experiment research strategy aims to determine what is the independent variable and what or which is the dependent variable. Okay, this is important because there are four variables involved in experimental research. So here are the four variables. One, independent variable. These are the variables manipulated by the researchers or experimenter. Number two, dependent variables. These are the variables observed for changes. So typically, the dependent variables are the behavior or the response measured in a research or in an experiment. Okay, number three, extraneous variables. These are the variables not included in the study but exists in the course of the experiment. Okay, next is the confounding variables. These are the variables that may affect or influence the dependent variable. Okay, so as stated at the goal or specific goals of a research experimental research strategy, the independent and dependent variable are the main source of what we call the cause and effect relationship. But the researcher must be wary of the extraneous variable and the confounding variables. So, well, what is the reason? Why do they need to look at the extraneous variables and confounding variables? The reason is that if they fail to eliminate all the extraneous variables and determine the confounding variables, the result of the experiment shall be what we call invalidated, or it may uh, portray a very substandard or inferior representation of the cause and effect relationship. Okay, so let's look at the diagram. In an experimental research, as we have said early on, independent variables are the ones which are manipulated. If the independent variables are manipulated, these are known as treatment conditions. So treatment conditions, if we have the treatment conditions, we need to establish what are the specific values that which are the specific treatment conditions needed to determine which value elicit more effect. So in a treatment condition, there is a level A and the level B. Okay, the levels are the different values of the independent variable. They create and define the treatment condition. Uh, in the diagram, we see that the independent variable, if the independent variable are manipulated, it produces the treatment conditions. And the treatment conditions, if you specify the different value needed to an experiment or the treatment, it's what we call the levels. So level A, level B. Then the results are now the effects or what we call the changes in the dependent variable. So here's an example of so here is the determining a true experiment. Okay, in the process of the experimental research strategy, we already know the two goals, and we know that the independent and the dependent variables are essential in the strategy. But there are times that the research or the researchers itself must determine if they are going to use this kind of strategy. So, okay, in order to determine if your experiment is a true experiment, there are elements needed to be considered. So, okay, a true experiment attempts to show that changes in one variable are directly responsible for the changes in the second variable. Okay, then this is the important part. It rules out the possibility of a coincidental relationship. So what we call the coincidental relationship is what we call accidental relationship. Okay, as we have talked about the four variables, the coincidental relationship, these are the uh, neglected, extraneous, and confounding variables. If the researchers fail to eliminate or what we call control the variables, the experiment itself would fall into the coincidental relationship. So here are the four essential elements of a true experiment. So one, manipulation. Manipulation, it consists of changing the value in order to produce treatment conditions. Measurement. Measurement are the variables measured by obtaining a set of scores. So the set of scores are gained in the different treatment conditions. Then comparison. The scores obtained in the measurement are now compared and contrast to see if there is a significant difference or significant relationship between the two variables and the different treatment conditions. Okay, number 4. Control. All other variables are controlled to guarantee that it will not influence the variables examined. Okay, in a true experiment, one characteristic is control, and it must, if not always, control must be the highest degree, control must be considered in the highest degree. Okay, let's have an example here. So here is a process of a true experiment. So one element, manipulate. We manipulate the independent variable to contain two treatment conditions, and those two treatment conditions contain uh, the level or the value of how do we, uh, how high or how low do we manipulate it, or how we um, change the value. So those treatment produces different set of scores. Those set of scores are measured and now compared to determine if there is a significant relationship between the changes in the dependent variable. Okay, so here is a concrete example. It's 2008, Paulman de Castro and Van Aken, video game violence and aggressive behavior. Okay, in their research, in their experimental research, they thought about the effects of violent games and the aggressive behavior. They thought about does violent games really produce aggressive behaviors, or it's just a coincidence that those who play violent games um, manifest or shows aggressive tendencies. So this is how their research went by. First, they manipulate the independent variable. So in their research title, the independent variable is the video game sessions because the aggressive behavior is known as the dependent, or it is the observed effect of the video game violence. Okay, so the manipulated video game sessions, they consist of two treatment conditions. One, playing violent video games, and the other is playing non-violent games. Okay, so in order to have the set of scores, they have the idea of observing those participants in a free play period. Then as the experiment goes by, as the observation goes by, they compare the two sets of scores and determine if video game, violence in video game produces aggressive behavior. Okay, in summary of their research, they have proven that those participants that engage in violent video games showed more aggressive behavior than those who are not, who are playing the non-violent games. But the key idea is this: the uh, they forgot that the population they have used are technically boys. So in the process of the experiment, they have thought out that in order to eliminate extraneous variables, which are the gender differences, they have what we call the control. So in order to combat the extraneous variables and the confounding variables, which are the gender, they have uh, undergo another research which contains a randomized set of participants which consists of the male and the female, or the girls and the boys. So in their research, they have shown that the four variables are very important because if Paul Manicasto and Van Aken forgot that the gender matters, it would be highly biased to the set of participants. In one of the statement seen on the research, masculine, or what we call boys have high inclination into violent games um, because of their temperaments and their what we call the uh, inclination to physical activities, which most of the time physical activities contains what we call physical contact and can be misinterpreted as aggressive behavior. So that's a key term that has been taken down, so or eliminated by including girls and boys in the set of their participants. Okay, let's move on. In a true experiment, we have causation. So causation, it is an empirical relation between two events, states, or variables such that one can change and brings the change in the other. So what do you mean by that? Causation, it, it provides the idea that this specific variable is the sole influencer, or the sole uh, um, it's the sole reason that this change happened. So that's causation. In a experiment, as we have talked about the aims of a experimental research, we need to determine the cause and effect. In the cause and effect, we have the causation, and causation elicits or have the third variable problem. So what do you mean by third variable problem? The third variable problem is the premise that a study may establish that two variables are related, but does not conclude that there is a direct relationship between two variables. So what do you mean by that? It is always possible that a third unidentified variable is controlling the two variables and is responsible for producing the observed relation. Okay, so let's go to the causation and the directionality problem. Okay, the first one is causation, the cause and effect. If we have a problem, or the directionality problem. We do not know if there's a direct relationship, or this variable is the only cause of this effect. We also have the directionality problem. Directionality problem, the results of the experiment cannot support the direction of the cause. So when we talk about directionality problem is the problem in which causation can establish relationship but cannot determine which is the direction of the causation. So how can we understand the idea of directionality problem? So we have a example here. So causation, third variable, and directional problem. The given example of an experiment is weight and mathematical ability. So they measured the uh, mathematical ability and the weight of the 6 and 12 years old randomized participants. So the main premise is this: when weight increases, as observed by the results, their mathematical ability increases. So in a basic sense, the dependent variable, a independent variable is the weight, the dependent variable is the mathematical ability. The research itself dictates that the weight, if the weight increase, the mathematical ability increase. So in a simplistic sense, we can determine that, okay, if weight increase, mathematical increase, there is a direct relationship. The problem is, what if we dig deeper to the relationship of weight and mathematical ability? This is a time when the third variable problem comes in. So how can we say so? Weight increases and mathematical ability increases because the age of the participants also increases. This is the problem. Why? Because if we fail to discover that there is another variable capable of changing the dependent variable, the experiment or the results would not matter. Why? Because it would be inconclusive to the idea that there is a direct relationship between weight and mathematical ability. Why? Because weight increase because the age of the participant increases, and their mathematical ability increases because the level of their education increases also in age. So that's a third variable problem. Then how about the directional problem? Directional problem, we do not know if the weight produces the increase in the mathematical ability, or if the mathematical ability increases the weight. So in this aspect, this is a problem in an experimental research strategy. So how can we bypass, or how can we solve this kind of problem? First, we need to establish that weight increases, mathematical ability increases. We need also to consider if age itself is a uh, influencer or a contaminating variable in the experiment. So we need also to measure the weight, the mathematical ability, the age, and determine if there is a increase also in their educational level. So there are many instances that this problem happens, and in order to solve, or in order to eliminate this kind of problems, we have the manipulation. Okay. So manipulation consists of identifying the specific values of the independent variables, um, identifying the specific values of the independent variables that is needed to be examined by creating treatment conditions. Okay, manipulations of the variable through its increase and decrease, can solve the directionality problem. And manipulation can demonstrate the lack of any direct connection between the variables. So how can we solve the problem in the weight and the mathematical ability? By the use of manipulation. Okay, first, we control the weight of the children or the participants. So if we have control over the diet, we manipulated the diet, we can conclude, or we can supposedly see if the weight increase, supposedly the mathematical ability increases. But if we can solve the idea that if the weight decreases but the mathematical ability remain to increase, or remain the capacity to increase, it means that there's no direct relationship between weight and the mathematical ability. So let's go on to the confounding variable. Um, it's what we call the intelligence and the age of the participants. We cannot manipulate the age, but we can uh, measure the intelligence of the participants. Also, we can determine the level or the educational level of the participant, which can matter on the experiment. How? Okay, if we determine that along comes, if the age increases, the level or the educational attainment or the educational level of the participant also increases. So if we're going to manipulate the, or not actually manipulate, or if we can control the educational level of the participants, we can determine if the IQ or the level itself are the sole cause of the increase in mathematical ability. Okay, so let's continue. In the element of manipulation, it is used to solve the third variable problem and the directionality problem. Okay, we have an example research here. It's from Fang Tu, Sheng, and Xiao 2019. It is Depression in Sleep Disturbance, a review on a bidirectional relationship, mechanism, and treatment. Okay, they talked about that depression and sleep disturbances are comorbid, but they cannot determine which comes first. So here's the question. Does depression cause sleep problems, or does lack of sleep cause depression? So here's a diagram on how they come up with the idea. So first, with manipulation, third variable problem, and directional problem. In the first area, the left side, sleep, they do not know if the sleep disturbance comes first or the depression. So in this design, it fails to determine the direction. So that's what we call directionality problem. In the other hand, by the use of a two experiment, first, they need to determine what is the independent variable. So the independent variable in their title is what we call the sleep disturbance. Why? Because keynote, the researchers cannot manipulate depression directly, but they can manipulate the number of hours and the um, hours of sleep of the participants. So in order to determine the direction, hours of sleep is manipulated. So we have the treatment conditions, which are the hours of sleep. So level A, so hours A. So let's say 5 hours of sleep. Then hours B, it's 8 hours of sleep. So the dependent variable is the proposed outcome is depression can or cannot be an occurrence and or the outcome of sleep disturbance. Okay, so in this in this in the right side, in this kind of diagram, with the use of the two experiment, so we have determined that the treatment conditions contains RS A and CARS B. That the dependent or the expected behavior is depression can or cannot be an occurrence and or the outcome of sleep disturbance. So in the process of their research, they have determined that um, there there is still a vague conclusion which comes first, depression or sleep disturbance. But one of the encountered confounding variables is what we call the gender, because as stated on the diagnosis statistic manual, depression highly occurs in the gender, or the what we call the uh, depression in statistics are more manifested in girls, or what we call feminine. So that's the third variable problem. So how did they solve the third variable problem in directionality problem? So first, in the third variable, they determine that only sleep disturbances and depression are the only available variables in the research by the use of medical diagnosis. So how did they do it? They they eliminate all the participants with um, different medical conditions prior or comorbid with disturbance of sleep and depression. Next, in the manipulation of hours, they had they make they ensured that the participants are all sleeping in a controlled environment and closely monitored without any other contaminants or influence. Then they had they used randomized technique for their participants, including both male and female genders. So with those manipulations, they have achieved the true experiment, and they can conclude that the results of their research are plausible and not contaminated. So let's move on. The next uh, element that we're going to talk about that is important in a true experiment is what we call control. Control is the second distinguishing characteristics of an experiment. This ensures that the observed relationship is not contaminated by the influence of other variables. Control is done by ruling out all possible explanation for the observed changes. Okay, the one of the key examples of control in research strategy is the 1994 humor on sentence memory by Smidge. Smidge, in 1994, conducted a series of experiments, investigations on the effects of humor on memory. He generated pairs of humorous and non-humorous sentences that had the similar context. So in the research or experiment of Schmid in 1994, here's an example of his stimulus. First, humorous. If at first you don't succeed, you are probably not related to the boss. Then the non-humorous, people who are related to the boss often succeed the very first time. So in his experiment, the control of the variables can be seen on the uh, control in the participants and controlled in the stimulus. So, okay, the experiment goes by having the participant presented with the different list of sentences, followed by a memory test to determine how many sentences they could recall. Then, the results were shown to the participants, and it concluded that uh, participants, the participants recalled more humorous sentences than non-humorous. But there are several concerns raised in Schmidt's experiment. So what are those concerns? So number one, were the participants truly affected by humor, or were they caught by surprise? The number two, does the IQ of the participants matter? Okay, so let's refrain on the experiment of Schmidt. The participants sat in a controlled environment in a testing room. Then the participants were shown papers with several humorous and non-humorous statements or sentences written. Then supposedly after those portrayal of humorous and non-humorous sentences, they undergo memory testing. The idea of the concern raised in the experiment, uh, Schmidt was concerned if the humor was the only factor affecting the increase in memory, or there is a sense of surprise which can affect the attention of the participants to the sentence. Okay, so here is the flow of Schmidt's experiment. So the effects of humorous sentences on memory. So they have the two different treatment conditions. They have um, two sentences available. They have the humorous and the unhumorous. After the participants were presented with these statements or sentences, they have undergone memory test. So the main concern of Schmidt is that maybe age, maybe IQ, or maybe the room condition can affect the um, can affect the results of the experiment. So he, by the power of the element of control, on the age, he have the restriction age. So he controlled the age group of the participants' IQ. So he failed to determine if IQ can influence the results of the memory exam, the room condition. Okay, as stated early on, Schmid had controlled the testing environment by um, having the examinations and the presentation of the humorous and non-humorous sentences in a testing area, which is controlled and set only for the experiment. So upon deduction, the variables or confounding variables that Schmidt found that can affect his experiment is the surprise and the IQ. So ruling out the IQ, um, he ruled out that IQ is a variable, but not uh, but is but IQ is not the only factor that can affect the experiment. So in response to that kind of problem, Smith determined the range of the IQ, which eliminated IQ as a confounding variable by including it also on the description of the participants. The main premise or the only thing that is left as a problem is the level of surprise. Okay, in order to combat or in order to have a proper response for the elimination of confounding variable in his study, which is the level of surprise, the question constructed is that does the participants recalled the sentences because of humor, or is it because of its surprise? So in order to eliminate the problem, Schmid modified or manipulated the process of the treatment conditions. In what way? Schmid um, Schmid included the instructions and the disclaimer on the paper before uh, the participants could see the main humorous and non-humorous sentences. So they were warned in the beginning that it would be humorous. Therefore, he eliminated the level surprise by providing a uh, disclaimer or providing a warning that the elements or the sentences involved in his experiment are all funny. So that's how Schmid controlled the experiment and manipulated the variables in order to attain a true experiment. Okay, so in controlling an experiment, there are different types of techniques in order to control the extraneous and the confounding variables. So one, holding constant. Okay, this is done by standardizing environment and procedures in the participant variable, restriction range, or committed. So what do you mean by restricted range? Restriction range, it's limit the possible participants by gender, by age, by IQ, by personality, or by mood. Number two, matching values across treatment conditions. This is exercised by matching levels with the use of balance through all treatments. In example, time control. When you talk about matching values across treatment conditions, per se, you have 30 participants, you have 20 girls or 20 female, then 10 male. The main idea is in matching values, you need to balance out the treatment conditions for the girls or the feminine and the masculine. Next, matching randomization. So matching randomization, this is done by utilizing a random process to prevent systematic relationship between variables. So in randomization, we have the random assignment, the random process of assigning participants to treatment conditions. Okay, as example, you have 20, 20 females, then 10 males, holding constant. It's either you eliminate all the female, having all male participants or respondents, or the other way around, you have all female respondents. That is holding constant. Next, matching values across treatment conditions. Okay, for example, you must conduct the experiment 20 minutes per session. Therefore, it must be considered that all treatment scenarios will suffice or will consume 20 minutes. So that's time control. Next, if the experiment were done in the morning, therefore, the other set of participants must experience being experimented on in the morning. So we have two set conditions, one in the morning, one in the evening, in the idea of matching values across treatment conditions. Group A are experimented in morning. Group B is experimented in the evening. On the next session, the group B must experience being experimented in the morning, and the group A should be experimented in the evening. So that's how you match values. Next, matching randomization. So random assignment. If you want to have a solid or what we call unbiased selection of participants, you can use randomization. So here's a table. It came from the 2016 Cengage table 7.1. So here are the different methods to prevent confounding. So it focused on gender. So letter A, gender confounded. Okay, if you can see the table, the separation or the allotment of gender is systematic, or you can see a pattern. So in order to eliminate that, we have the constant. So you decided to have all female respondents, or on the other way around, you have all male respondents. The next, gender matched. So if you can see the match values, all the treatment in treatment 1, you can see that there are 4 males and there are 6 females. In treatment 2, supposedly they should match, or they should equal, they should remain an equal value in order to have what we call the systematic and unbiased treatment. So last is the randomized. So this is where the highest degree of what we call control can be produced. Okay, in a control group, there are two classifications. There is the experimental group and the control group. Experimental group, this refers to the treatment condition in an experiment. So this is where the manipulation uh, happen. This group is where you use the uh, this is where you use the behavior conducing events. For example, if you are going to test the uh, efficacy of paracetamol, experimental group would be the group would take the medicine. Then the other one is the control group. The control group refers to the no treatment condition in an experiment. So if you're going to test the efficacy of paracetamol, you are going to use experimental group, which would take the medicine, and the control group, in which they are bound to do nothing. In in the groups, we have the placebo control group. The placebo control group is a group where they receive fake medical treatment, and this group are supposedly testing to show the ineffectiveness of the treatment, or it can also show the of the uh, effectiveness of the psychological uh, it can be it can produce the psychological effect. So you can see the psychological effect of in a placebo control group. Okay, so when we talk about placebo it is an inert or innocuous medication that may cause dramatic effect on the health and behavior. So if you have given them a placebo, the placebo effect is bound to happen. A placebo effect, this is the response of the participant to the inert or fake medication given. So in a control group, we have the idea that the experiment have the two differentiations. One is the outcome research and two is a process research. Outcome research, it is determined in which uh, this is determined to see if there is a significant effect, there is a significant effect in the treatment process. In the process research, this is used to identify the active components of the treatment. So in summary, outcome research is based on the outcome. Is there a significant effect, or there is a degrade on the effect of the treatment? In the process research, the overall development of, or what we call the progress of the treatment are observed. So these are the two experimental research groups. If you can see on the uh, uh, diagram below, you can see the experimental group, control group, and the placebo effect group. So going back to the different kinds of control groups, um, both the experimental and control group are necessary. Placebo effect group are used a um, in order to have a record on how would people act if they are supposedly taken in the treatment. So we can compare the group in which there is no treatment, there is a treatment, and there is a fake treatment, which uh, can benefit on adding data on the behavior response or the effects of the treatment or the medication. So in order to have a good experiment, we also need to have the manipulation checks. So a manipulation check, it is uh, it is a direct measure in which the independent variable are determined if it has a significant effect on the participant. It is an additional measure to assess how the participants perceived and interpreted the manipulation and or assess the direct effect of the manipulation. To conduct a manipulation check, it is necessary to check the mood of the participants and their feedbacks. This can be done by giving an exit questionnaire. So the questionnaire contains different questions. For example, did you notice this? Are you aware that? In example, in a manipulation check, after the experimentation have done, after the treatment conditions are met, the researchers and the experimenters are obliged to uh, get the feedback or the responses, or what we call the perception of the participants involved. Why? Because the participants itself must be debriefed, and they have the experience of undergoing the experiment, which cannot be uh, subjectively be experienced by a researcher because of their observational status. So in a manipulation check, we have four. Number one, participant manipulations. It is the idea of asking the participant with their perception and direct effects of the manipulation. Number two, subtle manipulations. These are the manipulation done in small changes, therefore checking for the participants in noticing the minor modifications. Number three, simulations. Manipulation checks are used here in order to assess how participants perceive and respond to the simulation. Then last one is placebo controls. Manipulation checks are used in placebo-controlled group in order to assess the realism of the treatment. Okay, in example, participant manipulation. So in a manipulation check in participant manipulation, you ask the participant directly how did they feel, how did they perceive the experiment, did they notice something, did they experience a change on themselves. That's participation manipulation check. Subtle manipulation, okay, these manipulation are done to debrief or um, to inform the participants that along the course of the experimentations, or the what we call uh, along on the experiment, the participants are informed that minor changes that there are minor changes happen in the course of a mediocre session. So what's the importance of that? It's to determine if they notice how the researchers manipulated the environment. If the participants are aware that the researchers are manipulating the environment, it can elicit or produce different results to the participants that are unaware of what's going on. So number three, simulations. So manipulation check in order to assess how participants perceive and respond to the simulation. Okay, they check if the participants experience the realism of the simulation. So if the participants found out that it's just a fake simulation, it could affect the overall results of the experiment. So number four, placebo controls. Manipulation check are used in placebo control group in order to assess the realism of treatment. Okay, after the experiment, you need to tell them that the medication or the treatment they have received is a placebo effect. Therefore, if the participants uh, are not aware or unaware of the placebo, it can detain different uh, different different results compared to the individuals or participants that are aware that there is nothing happening to them. So you need to compare the results of those who are unaware and those who are aware of the process. It could change the main analysis or interpretation of the results because of another variable that could manifest, which is the awareness. So okay, let's go to the simulation. So simulation is the creation of conditions within an experiment that stimulate or closely duplicate the natural environment in which behaviors examined would possibly occur. Okay, so a simulation, it can be uh, it can be a artificially produced environment in which individuals or participants um, are put in this scenario, and they are expected to act the natural instincts or their natural responses to a specific event. So that's a simulation. For example, in the play therapy, a child is a child is left in a room and then observed by the researchers, and throughout the process the child is not aware that he or she is being observed, with the context that he or she are free to do whatever he wants on that room. That's his simulation. So there are two types of simulation. One is mundane realism. So in a simulation, we have the realism. So it is the level of how the participants perceive the uh, real like, or the what we call the naturality of the environment. So we have the mundane realism. So this refers to the superficial, the usually physical characteristics of the simulation. This is the lowest degree of a realism, in which participants can feel the plasticity, or what we call the unrealism of the environment. Then experimental realism. This concerns with the psychological aspect of simulation, in which participants are immersed in the simulation and unmindful of the involvement of the experiment. So when we talk about experimental realism, it's the idea that the environment are so controlled, or um, uh, the environment are deeply detailed, that the participants inside of that environment forgot that they are in an experiment. So one sample of an experimental realism is the show in a TV in Channel 2. It's the Pinoy Big Brother. First, the participants experience mundane realism, in which they know that people are looking at them, people are recording their actions, but throughout the process, the psychological aspect, they began to adopt, and they possess uh, the uh, element of the experimental realism by um, adapting well to the environment, and thus being unmindful that they are still involved in the experiment. So that's an example. So last one is what we call the field studies. So field studies is a research conducted in a place that the participant or subject perceives as a natural environment. So in a simulation, most of it are done in a laboratory. So in a enclosed space. In contrast, a field study is the experiment or a study which involves um, the natural habitat or the natural environment of a participant. So in contrast, in a um, in experiment, in a simulation, it's in enclosed in a room. For example, is um, you want to determine the behavior of man if they are stuck in an island. So you are going to um, construct a room in which the simulation or the environment of an island can be experienced. So that's enclosing, that's simulation. In contrast, field studies, you're going to an isolated island, and you are going to leave a man dead there, and continue observe and record his behavior, in which how she or he would respond to his natural environment. So here's an example of simulation. In 1973, the Stanford University, it's what we call Stanford Prison Experiment. So in summary, um, a building were modified to um, are modified uh, to portray or to be seen as a prison, and then participants who volunteered on the research were randomly assigned to be a prisoner and a guard. So throughout the process, it's a mundane realism. They feel that it's plastic, but with a couple of days, the experimental realism occurred by the means of leaving the authority and responsibility to the prison guards, which uh, psychologically affect their what we call behaviorism, or their social interaction, and committed to the act of being the prisoner and being the prison guards. Next example of the field study is the acute effects of visiting the urban green environments on the cardiac cardiovascular physiology of a woman. So this one, they measure different kinds of women with uh, with tools measuring their heartbeat or the heart rate. Then they were observed with their consent on different gardens available in their vicinity, in which, in summary, uh, all of the participants experience a calmness and peace or serenity, or what we call relaxation in a garden rather than a uh, artificial made uh, artificial made park with uh, um, greenery, flowers, and vegetations. So in summary, uh, the researchers observed the women going to parks, going to gardens, and going to forestries. So that's my report for today, and that is the experimental research strategy. Thank you very much.